Okay, everyone, the time is now 7 p.m. And welcome to the National Weather Service Boston webinar. And today's topic is on the flooding and tornadoes from the remnants of Tropical Storm Ida. And and for those of you who may not be familiar with our website, you can find all the webinars that we have covered on our YouTube page. And if you go to www.weather.gov/Boston/webinars. You can register for our webinars that way. And Joe is actually not available to join us tonight, so we would so I'm hosting the webinar on behalf of Joe. And here are the presenters tonight. My name is Rodney Chai. I'm a meteorologist with National Weather Service Boston. And together with me tonight, Hayden Frank, lead meteorologist, and Bill Leatham, meteorologist with National Weather Service Boston. And here's an overview of Ida. Just basically, record amount of rainfall fell in parts of the Northeast that resulted in historic flash flooding, primarily in the Mid-Atlantic area. New York City and Philadelphia, and you can see here the numbers, just really eye-popping numbers. And unfortunately, there were dozens of fatalities across New Jersey, New York State, and as well as Pennsylvania. In addition to the flooding, there were several tornadoes that occurred in New Jersey and eastern Pennsylvania, including an Ef3 tornado just south of Philadelphia. And there were also flash flooding in southern New England, but thankfully we did not have any fatalities in our CWA associated with the flooding. And we did also confirm one EF0 tornado on the Cape. And so at this point, I will pass it to Hayden, who's going to bring you through the first part of the slides tonight.
All right. Great. Thank you, Rodney. And glad everyone could join us tonight. I'm actually doing the forecast overnight and it's tomorrow, another flooding situation, but nothing like this. So I am going to bail on this presentation after I do the first part here, and I'll be turning it over to Bill Leatham to get more into the meteorology. But I want to kind of give an overview of the situation, as Rodney had mentioned. It was the remnants of Ida, as remember, that came in as a very strong hurricane into Louisiana and weakened in terms of its wind fields. But as this event really emphasized the importance of not letting your guard down just because the wind fields had weakened, dozens of fatalities were in the New York City metro area into New Jersey from the flash flooding, the devastating flash flooding, which many more fatalities that actually occurred when the hurricane made landfall in Louisiana. So just an important thing that we all have to keep in mind. So this is a satellite imagery giving an indication of the track of Ida, and you can see how it lifted northeast. One's kind of a nighttime image, the other is the IR imagery. But what you'll notice is those really bright colors. That's a really good indication of where your heaviest rain fell, the thunderstorms, all that torrential rain. And it wasn't just the amount of rain that fell, but it was how quickly it fell. So as we move on here to the next slide, you'll see a good image of the hurricane. This was when it was a very strong Category 4 hurricane that was about to move on to the Louisiana coast. And one thing you'll notice is how very symmetrical it is, a kind of classic image. You have your eye there, and then the intense thunderstorms, or as we call them in meteorology, convection. And that's where your really strong wind fields are. As these tropical systems move northward, especially as they get into the northeast, they tend to change their structure so that the wind tends to be on the east side of the storm and the heavy rain and flooding tends to be on the western portion of the storm. And this is going to be a good example of that, which we're going to show here in a bit. But right now we can move on to the next slide. And as we all know, we've seen the pictures, the devastating and tragic flash flood that occurred in the New York City, New Jersey metro area. So this was the first ever flash flood emergency issued for New York City. So I just kind of want to give an idea, a general idea of the difference here. So a flash flood warning is issued when dangerous flash flooding is happening or will happen soon. Some roads, businesses will be flooded. And, you know, this is serious in itself. But a flash flood emergency are extremely rare. Very, very rare situation when there is a very large threat to human life, potentially catastrophic damage, a major, potentially historic flash flood is already occurring or will happen very soon. So if you ever hear the word flash flood emergency, that gives you an idea of how dangerous the situation is. And fortunately, those are very rare, but when they happen, that's where action needs to be taken because of, you know, what we saw in this event, the tragedy and the large loss of life that we hate to see. So we are going to take a look at some pictures on the next slide, and these are from New York City area. And what you notice, other than the water's obviously rushing through the New York City area, you don't usually see images like that, you know, on the I-95 corridor. But a lot of people underestimate the strength of water and how quickly it's moving and how quickly you can get into trouble in these situations. When you see rapidly moving water like this, even if it doesn't appear that high, never ever attempt to drive through it because it could wash your vehicle out. The road may not be there anymore. Part of the road may have already caved in, and we'll see pictures of that. But again, when you see water moving like this, do not drive through it. If you remember anything from this presentation, that is a really, really big takeaway. So let's go on to the next slide here. And again, you just see the fury of this water, you know, coming into the area, first through the roads, and then it's where a lot of the tragic situation occurred. Is if you see the image on the right, there's water in this gentleman's basement. You see him walking there. So there's obviously an issue. Obviously, there's already flooding, and then you'll see, you know, what happens through the wall. Just that rush of water comes right into that basement. So, you know, tragic event here in a lot of these cases. But again, the lesson learned is, you know, if there is water coming into your basement and your area is under a significant flash flood, not to go in there because of a situation like this, especially when you have the amount of rain that was seen in that area. And we're going to talk about that here in a bit. So if we'll go to the next slide here, Rodney. And this is from Philadelphia. This is actually where I grew up. And again, it's kind of hard for me to even imagine this was real, because for all the years I lived in Philadelphia and never saw anything even remotely comparing to what happened. So this is I-676. It's the major expressway through the Philadelphia area, right through the heart of the city. And you can see, you know, what it normally looks like, and then what it looked like a day or two even after it. I mean, again, you could just see all the water from the Schuylkill River flooded in there. There was so much rain, so much of it occurred in a short time, and on top of it, it had been such a wet summer. So definitely a, you know, historic flood event in the Philadelphia area too. And again, a lot of times we, really emphasize the importance of not driving through flooded roadways. First, you don't know how deep the water actually is, and you also do not know if the road is actually intact anymore. Because when you get water that's moving that quickly, um, the road may not be structurally sound, or it may have been torn up, and you won't know that because the water's on top of it, so you don't know. And then you drive through it, and this is exactly what happened on the left here. Cars didn't realize that the road had already been washed out, and unfortunately, these type of scenarios can lead to fatalities as well. And a lot of this, it won't even be known till the light of day. So this was in Portsmouth, Rhode Island, on the upper right image here. And what you'll notice is that just the roads completely buckled from the flooding that occurred during the overnight hours. But we were not aware that this had happened until the morning. So you can imagine, an unsuspected driver just going down the road, and it's part of the road's washed out. So that's why this is such a significant thing with flooding, and why there are fortunately so many more fatalities than people realize from flooding, as opposed to the other type of weather events, tornadoes and those type of events. People tend to take more action on those when they hear the word tornado, but flash flooding is nothing to mess around with. So let's go to the next slide here. And again, an example of the amount of rain that fell from this. This was in Willimantic, Connecticut. On the image on the left, you could see how rapidly that water is flowing compared to normal. That's not normally how it looks. You'll also know there's appears a couple people up there. Again, the fascination of taking images of water rushing like that obviously is understandable, but it's extremely dangerous and shouldn't be done, because when the water is flowing that quickly, you don't know if this bridge is going to hold the structure. So again, goes back to kind of the importance of safety. And again, you see the water spilling in onto the roadway here. In this case, obviously it doesn't look like much, but again, you don't know exactly what is here. Is the road partially washed out? And again, a lot of the flooding that occurred in our area occurred overnight. So we'll take a look at some more pictures here. And again, they're all really kind of pointing at the same thing here. Just a lot of flooding. The difference between this event and a normal flood event is areas that don't normally see flooding during a regular flood event were experiencing significant flooding during this event. So that can be particularly dangerous when areas that aren't accustomed to it, get inundated like this. So again, the perception from the human eye is to underestimate the power of water. 6 inches of fast-moving water can knock an adult over, carry them away. Only takes 12 inches of fast-moving water to move a car, which is not that much when you think about it. And then 18 to 24 can carry a big SUV, some of those big vehicles so many people feel very safe in. Again, this is really important to remember. And the other thing to keep in mind is it's really tough to estimate just how deep that water is, especially at night. So looking at the track of Ida and the total rainfall amounts. So again, there's no standard for this. All tropical systems, remnants of tropical systems, whatever they are at that point, the rain fields can look different between the movement, different places of frontal boundaries. But notice one thing here, especially on the image on the right, you can see the typical situation where the torrential rain and the flooding is west or north of the track. And that is common transition as these tropical systems try to transition into our typical stuff, typical nor'easter that we often see, where you have that main shield of heavy precipitation to the left of the track, and usually the wind and storm surges to the right of the track. Fortunately, in this case, the wind field had weakened. That wasn't very problematic, but this was all really focused on the heavy rain and flooding, and there was obviously a localized severe weather threat near and east of the track, which we'll talk about in a bit. But this is one thing we keep in mind when we think about tracks of tropical systems. Just because the center of the storm may be 150, 200 miles south or east of you, doesn't mean that you're not going to get the main or worse impacts from it. So it's important to keep that in mind. And we'll zoom in here a little bit. This was the 1 hour precipitation radar derived estimate, and you can see the tremendous amount of rainfall that occurred in a very short amount of time, right over the New York City metro area, into New Jersey, into Connecticut. When you're talking about 3-4 inches of rain in an hour, in a highly urbanized area like New York City, you're gonna have big problems, and unfortunately that's what transpired. And just to give you an idea how quickly this rain fell, this is 5-minute intensity. We had basically over a half inch of rain in 5 minutes. So just think about that, a half inch of rain in 5 minutes, over a half inch, how quickly that was coming down. And unfortunately, when it's in an urban corridor like that, there's nowhere for it to run off. So this is the observed rainfall in our region. We had a lot of flooding, a lot of flash flooding, especially south of the Massachusetts Turnpike. Our area, even though we had significant flooding, we were spared the historic flooding that the New York City area, Philadelphia area was dealing with. But we had significant flooding, 3 to 6 inches of rain, a lot of 6-inch totals. South of the Massachusetts Turnpike, there were some 7-8 inch amounts in there too. So this was a very significant event, even in our area. The one thing that spared us a little bit is it occurred during the overnight hours. So fortunately, you didn't have as much traffic on the roadways. So again, looking at our, normally for the month of September, you're looking at, 3.5 to 4.5 inches of rain for the entire month. Basically, a lot of these places got that much or more rain in a span of 6 to 8 hours. And this is a look at various river flows across the country. And you can see the dots, the actual dark colors there, where either we were running much above normal or all-time high stream flows for that day. Keep in mind, we don't usually have stream flows like we do in the wintertime when there's like a lot of, could be snow, there's more, widespread rain or obviously snow events. But this gives you an idea from Philadelphia right into southern New England. Pretty much all the stream flows were much above normal to all-time high for that specific day. Okay, this is a look at some of the outlooks issued from the Weather Prediction Center. And obviously there's a lot of images up here, but the takeaway is basically we're looking at nearly 60-hour lead times in flash flooding, with initial moderate risks followed by high risks, which are again high risk covered the warnings during the valid time period, and high risk are very rarely issued, especially for the Northeast. So we'll show some images in a bit here that really depict that, but really another image that, just to give you an idea of how extreme this event was, the recurrence interval. Again, this is an estimation, 1-day average, but you can see this area in the vicinity of the New York and Philadelphia area, where you're basically looking at basically a 1 in 100 year type of event. And, that doesn't mean, exactly where the heaviest rain is going to fall. It could be, 20 miles here, 20 miles there, but that is a really, really red flag. That's something very unusual, and possibly, life-threatening, which unfortunately occurred, was a signal for that there. So, want to really focus on these WPC Weather Prediction Center. High risks are a big deal. So, obviously there's a lot of statistics here, but the main takeaway here, high risks are only issued by WPC on 4% of days, but high risk days accounted for 2/5 of all flood-related fatalities. So they're seldomly issued, but when they're issued, they account for over 40% of flood-related fatalities and 9/10 of all flood-related damages. So the takeaway here is, if you see a high risk, that's a big, big signal and the potential for a life-threatening event, and need to be prepared for that accordingly. So a great graphic that the Weather Prediction Center put out actually a day or so before this event occurred. So they really did a great job with this. And during the event, there were a lot of, what we call mesoscale discussions issued by the Weather Prediction Center about the event as it was unfolding. First they kind of really highlighted the area where it's going to be, the worst. The flash flood warnings on there. But basically, the I-95 corridor, had excellent lead time, basically, in terms of, 3-hour lead time for New York City, before the flooding even occurred. This was like a special discussion issued out ahead of that, and about 6-hour lead time for the Philadelphia area. And you can see high-end potential flash flood emergency level rainfall impacts are possible. Again, this is hours before the event even happened. Okay, so communicating these type of events is the images that you saw from the Weather Prediction Center, and then this is something that we issued out. We also did indicate what the Weather Prediction Center was saying, but we have, for example, we have a flash flood watch out for Western Massachusetts and parts of Western Connecticut for very late tonight and into tomorrow morning. The rush hour could be, quite difficult. But this doesn't compare to the ingredients that were in place for the event with the Ida remnant. So this is kind of how we try to highlight that. Not all flash flood watches or not all watches or warnings are the same. So rare high-end flooding potential Wednesday night into Thursday. So this was a couple days before, where we're saying, please review these 3 important flood safety tips, particularly if you're in areas prone to flooding. And again, as we got closer to the event, potential exists for rare high-end urban and small stream flash flooding, basement flooding, and a few road washouts. So really try to hit that this is not an ordinary flash flood watch. And one of the other things we passed on, which our emergency managers really liked, was kind of an overall event timeline graphic of how things are going to be developed. one of our younger forecasters helped put this together. This would be a little difficult for me to do with all these colors, but I'm learning. But basically, it really kind of conveys, okay, this afternoon, not such a big deal, but tonight increasing rain intensity, and you see this purple here indicating the worst is during the overnight hours. So really, really have to focus on the timing too, especially for emergency managers, those type of folks that really have to make those preparations, and when are things going to be able to improve. So with that, I am going to get to work on the forecast for overnight, but to turn it over to Bill Leatham, who's going to start getting into the details of the meteorology involving this event. So Bill, you got it from here?
Yes, sir. Thank you very much, Hayden, and good luck with the rest of the forecast.
All right, thanks.
All right. So one of the things that we look at going ahead into these events, this is looking at what we call an ensemble, a situational awareness table, and so what it does, because we've got so many different weather models and things to look at for events. Or for just forecasting events, this kind of helps pop out and show where there could be potentially big events occurring, like in this scenario where we're thinking like this, it could be a high impact situation. These tables kind of help point that out using there's an ensemble model that it's looking at here. And if you could see on the table on the left-hand side here, you've got things that say like there's different numbers, there's maximums, there's minimums, and basically it's saying on this models, when it's looking at like the models for these different time frames, it's kind of highlighting where there could be potential issues. So the one that we're looking at right now is on the 2nd of September, and it's looking at the V component of the wind, or another way to think about it is just the north-south component of the wind. And it's looking at the different levels of the atmosphere. If you're going on from left, it's basically from left to right and then up to down. You're going from higher levels of the atmosphere and lower as you go on. And what this is kind of pointing out is that it's a really anomalously strong north-south component of the wind. And then like a particular area that we look at, especially with this event, if you kind of think of like a traffic jam, when you're looking at the 700 and 800 level, you can see that there's this almost these really highly anomalous winds pushing into southern New England and even into parts of the mid-Atlantic. You can kind of think of when we have these traffic jam situations that happen, once the traffic's released, people on like the highway typically, will go speeding and get to their location. But in kind of in this scenario, what happens is we just get a lot of rainfall that happens fairly quickly. So this is one thing we're looking at, and it's showing that the wind is pretty anomalous for this time frame. And if you want to go to the next slide, Rodney. So the next thing we're looking at here is specific humidity, or on the table it's called the Q. Again, it's still looking at higher levels of the atmosphere as you go down, going from 500, 700, 850, then 925, so from up to down. And basically what this is showing is over the northeastern part of the U.S., we've got really anomalously high moisture values over the region, or in this case, it's called specific humidity, but it really is the same as saying moisture. And you can see, especially at, obviously in the higher levels, it's over our area, but you can see, especially, when you're getting into the lower levels of the atmosphere, that it's really highlighting the mid-Atlantic towards, New York City, New Jersey, kind of the areas where we were showing all the biggest, where the biggest impacts occurred. And this is about 30 hours prior to, prior to things happening. And then this is just another way, another kind of moisture thing that we look at. There's a bunch of different ways that we look at moisture. This is the integrated water vapor transport. And what it's showing is it's basically showing us that there's this high amount of moisture coming up into our neck of the woods. And for this forecast model that we're looking at, if you look at the coloring, once you start getting into the blue or even the teal color, that's when you're getting to things that the model, towards the things where the model doesn't usually see it. So there's a really high amount of moisture coming into our area, which isn't really surprising, given it was a tropical, a tropical moisture coming into the region. Now, another thing that was, kind of definitely very interesting with this event is since we're getting into the fall time, we're starting to get into the time of year, and you'll see this a little more in the coming months when we start talking about snowstorms and those different kind of things, where we look at, it's this thing called frontogenesis, but it essentially, it's kind of, when I was talking earlier about those winds where you really get the packing of the traffic, it's kind of similar to that. And where you usually have these higher values of in this case frontogenesis, that's when you're expecting there to be heavier rainfall. So kind of think about it the same way as kind of like that traffic jam idea that I was talking about a little earlier. But you can see that it highlights going from the mid-Atlantic and then into southern New England and even into parts of Maine. But again, still, we usually see this a little more in the when we're getting into the fall and the wintertime kind of deal, because this is usually when we're looking at for like heavy snowfall. But it is something we look at for very heavy rainfall, and obviously that's what happened with this event. And so there's many different ways that we look at model data to try to figure out what we think is going to happen. And one of the things that we look at for precipitation, and then again, you'll see a lot more of this when it comes to like snowfall. This is the one of the ensemble models, what they call plumes, and it's basically showing all the different forecast members within this model system, showing what precipitation amounts the model was expecting. The top left one is from the evening before the precipitation, from the evening before the precipitation had happened, and then the bottom right hand one would be the day of in the morning time frame. So just before things are getting going rainfall wise, and this is looking at LaGuardia Airport in New York City. And usually what we try to do is, if you look on the, if you look at the different lines that they have on there, when they're all kind of clustered together, that's usually when we think, okay, the models have a really good agreement. And then usually you're going to go with where most things are agreeing, because typically that's where that's usually a good bet, because you've got a lot of different, a lot of different models saying the same thing. But the thing that you can, at this point, you can kind of see on both of these images is there's a couple of members, what we call outliers, where they're higher or lower amounts than where the majority of the models are thinking the precipitation is going to be. And you can see a couple of members get up to 5 inches of rainfall over this period. And even in the earlier run, there was a 4.5 to maybe 5 inch rainfall. Probably more the 4.5, because that looks like it's from a later system for getting up to the 5. Now, I know I pointed out saying that, most of the members were clustered between, it looks like roughly 1 to 3 inches. So usually that's, what you'd go with the kind of a forecast with. However, with the highly anomalous environment that it was, we actually went outside outside the envelope of the different forecast models that are in here, because the observed rainfall at LaGuardia Airport was 6.81, so almost 2 inches higher than the highest model forecast from this ensemble model. So another ensemble modeling system that we use, the difference between that one and this one is that this one looks at a little bit higher resolution than the previous one. So on the right hand side is the 48, basically the 48 hour, what the rainfall amounts the model is going to is expecting it going to be. And you can see it shows 7 to 10 inches of rainfall. It is a little bit too far north if you based on what happens. But a lot of times, especially with this particular model, it's going to do a good job at showing you where there's the potential for something, but it might not exactly have the right location. So obviously, like we pointed out, it's a little bit too far north. And then another thing you can look at when you're getting into like 1 hour, on the left-hand side is showing the 1 hour where the rainfall amounts will be greater than 1 inch per hour rainfall. So that's where you're expecting, pretty heavy rainfall. And you can kind of see here that the model, at least early on, you see we got into the greens where there was some 60 to 70% chance, and maybe even some 80% chance where the probability of the rainfall in an hour being greater than 1 inch was high. But its values, just looking at here, it might have been a bit too low, obviously, based on what happened. Just showing another model that we look at for this event. It's called the National Blend of Models. It's basically a blend of all the different forecast model data that we have. It's also kind of like the ensemble models that we showed previously. But what's going to happen here is you can see there's a pretty good swath of roughly 3 to 5 and maybe even some 5.5 inches of rainfall. But the problem that you run into when you're looking at, like, especially this kind of data where you throw all these different blends in, is it's going to smooth out some of those extreme ends of rainfall. So that would be why. So this had the right idea, but the amounts were, again, compared to what we saw, especially in the New York City metro area and even into New Jersey, a bit lower than what happened. And then again, just showing, this is another way to view that same model that we were just looking at, but it's with some different locations. You got LaGuardia. I'm not on the top of my head, I forget what EWR is. And then obviously you've got Logan Airport. The yellow is the precipitation amount that was observed, and then the green line is the amount that the model forecasted. So you can obviously see, at least for up in our area, that it was obviously the amount was still a bit too low given the environment that we were in. But when you're looking at EWR and then LaGuardia Airport, it's much lower than what was observed. Almost 3, if not 4 inches lower than if you were using just this forecast model. And then on top of the flooding, there was also severe weather that occurred with it. I know Hayden had talked about it briefly, where we had there were some tornadoes across New Jersey and even into the other parts of the Mid-Atlantic. On top, wind damage, and then even up here we had the tornado in the Dennis area. But you can see here that this the various reports that we had across the region. So, usually in these situations, we coordinate with the Storm Prediction Center in Oklahoma, and in these kind of environments, we tend to get, there can be not only up in southern New England, but also Mid-Atlantic and in the the New York City area. You can get tornado environment, and you can see here with the warm front that's starting to lift into the New York City area. This is basically getting into that there's going to be a risk for some tornadoes, and they're basically giving an update to the tornado watch. That there could be strong wind gusts and a couple of tornadoes, and this is all prior to those storm reports that had shown on the previous, so that they knew what was coming up in this area. At least in regards to severe weather. And then when you go to the next image, this is the different tornado watches that were issued. The first one from a little after or a little before 1 o'clock in the afternoon that day until 10 o'clock at night for New Jersey into Pennsylvania, and also in parts of Delaware and Maryland. And then obviously the tornado watches expanded northeastward as time went on into the New York City area, and then eventually into southern New England, including eastern Connecticut, Rhode Island, and much of southeast, or pretty much all of southeast Massachusetts. So with it's kind of been the case for so far this year where we've had these tropical tornadoes. This is just a list of all the different tornadoes that occurred from Ida up in, I'm going to assume this is just pretty much what eastern region area, and it has also the tornado rating, and you can see obviously you've got the Ef3 with almost a 13-mile path length, and then if you go to the next slide, Rodney, you'll get into what our area had. We had the Ef0, which was in Dennis, Mass, with a 0.1 mile path length, and these weaker tornadoes tend to not be they tend to be not as long a path length because they're weaker, but obviously still something to be concerned about if you do get the tornado warning. And if you want to go to the next slide, and then this is so after we get a report of a tornado, if someone's seen a tornado or we suspect there was damage from a tornado, we go out and do damage surveys. And this is just an image from the Mount Holly office on that Ef3 tornado that had happened in their area, and you can see on the right hand side that's the path where things started, where things ended, and the different little triangles they got in there are different spots where they were surveying damage and what the rating of the damage was in that area. And then you could see here you've got a couple of the oranges which are showing that Ef3, and there is even several spots that had Ef2 damage from the tornado, and then also unfortunately there were two injuries from this tornado as it was going through. And then just again focusing on this Ef3 tornado, and I apologize if I botched the name here. I'm going to say it's Mullica Hill, New Jersey. You could see the damage from that occurred to several of the homes. This may have been where they had gone when they did the damage survey to help make the classification of the Ef3 tornado, because when we're going out there, we're basically crime scene investigators for the most part, of trying to put together based on the damage that we see what the strength of the wind was as the system went through. And then obviously in the bottom right hand corner you can see the GIF of the tornado that was going through the area at the time. So taking a look at the radar signature, you can kind of see what we call like almost a classic supercellular signature or tornadic signature, where you've got this hook on the radar, and then you see this increased value that we have highlighted here. It's a debris ball, basically saying it's hit something. We don't know what, but there's debris being wafted into the air that the radar is picking up on. And the way that we kind of confirm that is by looking at on the bottom right hand corner is the correlation coefficient. It's just another thing that we look at on radar, and if we start getting these really low values, that's when we can tell it's something other than rain or snow or some kind of precipitation like that is falling. And we don't have it here, but I'm sure if we had a velocity image too, usually that'll match up with where we think there would be a tornado, where you'd have like you would kind of see, you would see it on the image. I'm sure if you've been on the webinars before, you've seen them in the past. So if you want to go to the next one, Rodney. And then another thing that we do look at when we're trying to when we're putting out the warnings, especially if you've got like a debris signature, there's something that we look at with, depending on how high the debris has been lofted or thrown up in the air, that can help give an idea on how strong of a tornado it is. And the higher the debris is lofted or shown in like this image here, the stronger the tornado can be. So that would be a time where if we saw this with like an initial tornado warning, they might up the tornado warning to catastrophic, or the different levels that we can add when we're putting out warnings. So as I kind of pointed out, at least in our area, we did have the tornado in Dennis, Massachusetts. It happened really early on in the morning, around 1:30, and it lasted for less than a minute. Again, it was only 0.1 mile path length, and you can kind of see in the text here what damage had occurred. But it was, compared to that Ef3 that we were looking at, obviously much weaker. Still obviously nothing to scoff at, because we don't get tornadoes all that frequently, especially at nighttime or even over on the Cape. But we did have a tornado in this environment with we also had the watch out with it. So yeah, if you want to go to the next one, Rodney. So to kind of go a little bit more into the environment. We talked about that warm front that was lifting northward. That's also, was lifting into our area too, but it was a little bit, obviously a little bit later at night than what was in the New York City metro, when I was in the New York City metro area. And the one thing that you could see is we've got all this instability, but really it's mostly over the ocean. It's really not over the southern New England area, except for maybe right along the coast. But we're within this gradient region, which, where you've got almost, again, it's almost like the traffic jam idea, where you've got, you're in between some really high values, and then there's some lower values. And we, especially when it comes to tornadoes, and even in other severe weather environments, you never really want to trust areas where there's this gradient going on. And one thing you can kind of see, if you can see it, there's these little circles that the model is showing here. That's indicating like stronger thunderstorms, where there could be a severe storm or two in there, and you can kind of see that it highlights, right along in that gradient region where there could be some severe weather. So another one that we look at, that was the instability. This is what we call storm relative helicity, or another way to kind of think about it is how much spin is going to be available for the storms to use. And this is, these amounts are really high for a typical environment. It's not really uncommon, especially given we've got a decaying tropical system coming into the area, and you can kind of see that it highlights pretty much all of southern New England, especially along the south coast. It does get into parts of central Massachusetts, and even into like northeastern Massachusetts, but the real risk would be right along where that kind of where we were looking at before, where the instability gradient was, and then when you've got these really high values of storm relative helicity. And then this is showing the model's maximum updraft helicity. So basically, it's kind of how strong or where the strongest storm's going to be, and it shows all these different little areas, because given the high resolution model that we're looking at, and you can see most of that, as we kind of talked about before, all the greatest instability was offshore. But you can still see that most of the higher values were focused in across the mid-Atlantic, but you almost get this local maximum. It pokes into the south coast if you look into like Cape Cod and also the islands. So there was the risk there. It was at least based on this, it was low, but there was still the risk given the environment that we had. So kind of going from looking at like the really high resolution, looking at like the storm scale stuff, you also need to look at like what's going on in the broader scheme of things. And so the environment that we had here, you can kind of see in the light blue is what we call like this would be like a jet stream, or in this case is like a jet streak. And typically when you're in the right entrance region or right rear quadrant of the region, it's going to be a good area for strengthening low pressure systems, and it's a really good region for lift for like things lower and lower levels of the atmosphere. And we've got a really strong 100 plus knot jet. So this is basically saying that if you look over southern New England and into the mid-Atlantic, it's a good area for something to happen, given there are other ingredients in place in the lower levels as well. And so then when we jump down a little lower in the atmosphere at 500 millibars, or roughly 18,000 feet, we still have a strong wind maximum over southern New England, which with when you have a stronger winds aloft, that does also enhance the risk for flash flooding. And if you can bring any of these winds down, that also brings the potential for the damaging wind threat. And this also, the pattern that we had set up, I don't know if we've talked about in past event reviews, but it fits like a synoptic type B pattern where you've got a trough coming in from the Great Lakes. And this is a scenario where we can get tornadoes, and obviously, in this case, we did get one. So jumping down a little further in the atmosphere at 850 millibars, or about 5,000 feet, this is where you're starting to look into getting into like where the warm fronts are, and you can kind of see that this warm front basically going from northern New Jersey and then poking into southern New England. You can kind of see that we've got the warm front that's lifting in, and then if you kind of couple it with the features that we previously looked at, this system's going to keep strengthening, and we're probably going to have showers and thunderstorms associated with this front as it's lifting in. And then the other thing, it might be a little hard to see, but we've got southerly flow, which is bringing in all this moisture in from the Atlantic, and then obviously we've got the moisture associated with Ida in there as well. And although you'll see that a little better in a slide or two later. And then again at the same level, but this is looking at one of those moisture things that we looked at, the integrated moisture transport, and you can kind of see all this moisture is streaming into the region with the colors, the darker red you go, the higher the moisture is that's coming into the region, and you can see that's all the moisture that's kind of headed up into our neck of the woods. And also, maybe unsurprisingly as well, you can see, all the highest moisture values is right where all the heaviest rainfall had occurred. And I think with that, I believe I'm passing it along to Rodney to talk a little bit more about the moisture in the environment.
Well, thank you, Bill, and thank you, Hayden. In the interest of time, I would just briefly go through the last few slides that we have. Because this is such an significant event, and there's so much to talk about, and we know we've thrown a lot of information on you, and I do want to be able to get to some questions, and a lot of the questions Bill and we have already answered it in the the text box that is provided that you can see on your screen. So yeah, you can see here's the P watts or precipitable water. Basically, it's how much water the atmosphere can hold, and this is the amount of rain that can fall from it if everything is released at once. So you can see just a sheer amount of water in the atmosphere with this system. And going back to the Ef3 tornado on the Cape, and notice there's not a whole lot of instability associated with this is not a high-end severe weather event, but the conditions were enough for a weak tornado to spin up, and in this case it was the favorable location were along the south coast, Massachusetts south coast and Rhode Island south coast, and we ended up getting a tornado near Dennis. And what you're seeing here is what we call the ML Cape, the mixed layer Cape or instability. The values here are not very high, but you do notice kind of like a gradient, very sharp cutoff from just off the south coast to the Massachusetts south coast, and this is where we, as forecasters, we want to be alert to this kind of setup. Very marginal instability, but just enough of a gradient to favor a brief rotating storm. And again, this is the 0 to 3 kilometers Cape and surface vorticity or atmospheric spin near Cape Cod at 1 a.m. And and when you have this kind of setup, basically where you overlap the blue lines and the red lines, and in this case, the overlap areas on the Cape, and that was where we had the Ef3 tornado in the middle of the night. And just want to show you briefly this is one of the derived products from the Storm Prediction Center. You can see on the left-hand side, that's the probability of an Ef3 tornado. You can see basically, 15 to 20% probability of an Ef3 tornado across Cape Cod and the islands. And there's even a non-zero probability of an Ef2, which would be more of a stronger, more violent tornado. And I like to tell people, never trust a warm front when you have possible severe weather. And in this case, sure enough, there was a warm front that was draped right across Cape Cod in the middle of the night, and the tornado basically happened near the nose of that warm front, and that's approximately where Dennis, Massachusetts is. And and this, just want to show you this is the sounding depiction of the atmosphere vertical profile over New York City at a time where the catastrophic flooding occurred, and you can see a very deeply saturated atmospheric profile. So basically the atmosphere is loaded and ready to go. Just a quick radar loop of what happened around the time of the tornado warnings for Cape Cod. And just want to show you quickly that's a lot of weather enthusiasts, people who are very passionate about weather, during severe weather, you pull out your radar app. It is understandable to focus on velocity couplets, but not all velocity couplets produce a tornado. And in this case, there was no damage reports received. So, we ended up issuing a tornado warning. There was a tight velocity couplet. There was even some kind of like a hook signature to the radar reflectivity, and even some kind of a debris signature, and even the normalized rotational signature. But in this case, despite everything seemed to line up perfectly, there were no tornado reports. And this was 1:15 a.m. and in this case there was another velocity couplet approaching Dennis, Massachusetts, and you can see in this case you know, one of the, the tips as a for a forecaster, if you want to, when you want to consider issuing a tornado warning, is to calculate the rotational velocity. Basically, you take the mean of the inbound velocity and the outbound velocity. So you take the average, and that you get the rotational velocity. So 35 knots. It would be unimpressive in a in a high-end severe weather environment. You want to see like 50 knots or more, but in a tropical environment, that is enough. In this case, a tornado was reported on the ground. So in summary, there were record amount of rainfall that fell in parts of the Northeast that resulted in historic flash flooding. It's not just the total amount of rain, but it was just the sheer ferocity and intensity of the rainfall. We showed you the graphic earlier on that you had over half an inch of rain in less than 5 minutes. So basically, if you extrapolated over an hour, that's basically 6 inches per hour rainfall rate, which is basically, I think very few cities are built for that kind of rainfall rate. And New York City is an urban jungle, so which really exacerbated the flooding, and unfortunately there were dozens of fatalities. And in addition to the flooding, there were several tornadoes, including an Ef3 tornado just south of Philadelphia in New Jersey. And so, and across our area, there was an Ef0 tornado confirmed in Dennis, Massachusetts. So, the key takeaways really in this case, and really that this helped to answer some of the questions that some of you have. The forecasters, not just in our area, also in New York City office, we identified a high risk of significant flash flooding very early on, and we collaborated with our partners, in this case the Weather Prediction Center and the neighboring offices. We had our conference calls with the WPC more than 3 days prior to the event, and WPC issued a very rare high risk excessive rainfall outlook 48 hours out. So and we also communicated the low risk of big tornadoes very early on, and the emergency managers, the TV mats, they all appreciated the early heads up, and we ended up getting an Ef0 tornado on the Cape. There was adequate people in the office for the event. You could always use more people, but hindsight is 2020. And again, we know the communication is highly important in such a highly anomalous event. Thankfully, no fatalities across our county warning area. But no one could have foreseen the high number of fatalities in New York City and New Jersey, which included geopolitical factors that are outside of our control. And one noteworthy thing is, and again very unfortunate, the number of fatalities across the Northeast and Mid-Atlantic outnumber the deaths in the Deep South where Ida made landfall. And again, there were people who died in their home, in their basement homes in New York City, and a lot of them are illegitimate apartments, and that's why I say there's a lot of geopolitical factors that are outside of our control. And if you have a tornado warning at the same time, as a flash flood emergency, what do you do? And that was a dilemma, and that's something that the New York City office, I'm sure they would have an after action review together with their emergency partners and the city officials. And yeah, so at this point, this brings us to the end of the presentation, and I would just answer any remaining questions that we have. Let's see. And I'm just going to answer the questions that we have not responded to in the chat. So Ethan asked this question: are gradients being favorable environments for severe weather typically a result of the location of a warm front? And Ethan, yes, actually, the warm front does have a role to, that is a contributing factor to the gradient. In this case, you have a gradient of MLK or mixed layer instability, and it has a lot to do with the temperature profile. So the short answer to your question is yes, and that's a great question. And Ethan also asked the question, what other types of synoptic patterns are there beside type B? I'm not sure of this off the top of my head. Bill, do you know
I can
the answer?
it there, Rodney.
Okay, thank you.
I got the presentation up. So we actually have so there's 5 different types of synoptic patterns for southern New England's tornadoes. Obviously, we talked about type B, which is a trough over the western Great Lakes, and but there's a type A where you have a closed low over southern Ontario, a type C, which is a strong, like a singular deep trough over the Great Lakes. D and is where you have like a tropical cyclone. So this might be kind of more of a hybrid of like B and D, which is a tropical cyclone or remnants of a tropical cyclone. And then type E, which is where we've got really cold air aloft, and you can get some brief tornadoes with the cold air aloft.
Well, thank you, Bill. And Ethan, you have your answer to that question. And also another question from Ethan. So how far up in the atmosphere can fronts extend? So again, that's a very interesting question. So typically when we talk about cold fronts, warm fronts, we talk about air mass that are close to the surface. But of course, an air mass is not just it's not limited to the surface, but it extends way up into the atmosphere. And I would say, Ethan, it's what we are really interested in. I would say maybe it's in the bottom 5,000 to 10,000 feet of the atmosphere, and and another thing I would add is that the cold air is dense, and they tend to stick to the ground. And so, in a situation where you have, let's talk about a warm front. So cold air is denser than warm air. So, in this case, let's say we have southerly flow, and so the warm air would actually, because the cold air is kind of stubborn and it's more, it's dense and it stays there, and so the warm air would actually basically get lifted above the pool of the cold air, and in this case, it can lead to all kinds of warm rain processes, and I believe if you look into our weather, either 101 or 202 webinar, you would have a more detailed explanation of what happens when you have warm air advection. But in short, when we think about a warm front, cold front, we really typically, talking about 5,000 to 10,000 feet in the atmosphere. And let's see. Okay, so also Ethan also asked the question, what should someone do when they are under a tornado warning and a flash flood warning at the same time? Again, great question. Fortunately, this does not happen very often. But if in the event it does happen, I would say you probably want to, if you can, head to higher ground. And also the thing is that before you have a flash flood warning, usually would be preceded by a flash flood watch. And in this case, if you live in a mobile home, or if you live if in a basement apartment, you really should be thinking of where you want to go in the event it gets upgraded to a warning. So you need to kind of have a plan laid out ideally. And unfortunately, what we saw in New York City, that was just very tragic. People drowning in their homes, and it's really, again, it's really not due to a lack of communication or warning, but in this case, they're just other factors that are outside of our control. So let's see. I think we have a question from Sebastian. Say, do you think that the reason ensemble forecast guidance may regularly underdo rainfall totals is because of the sheer amount of models that are used for the ensembles? So Sebastian, so when we are looking at the forecast, let's say 4 or 5 days out, you don't want to be too fixated on what an individual deterministic run gives you, because sometimes they may tend to overdo certain forecasts, and be it whether you want rainfall forecast or snow forecast, and the ensemble guidance is basically made up of different members, and you take the kind of like the average or the mean of these different members, so it kind of smooth out the noise of. But in this case, you have a very highly anomalous event, and if you are confident that this event is going to be highly anomalous, it's going to be not your typical run-of-the-mill event. As a forecaster, you probably want to look at some of the more extreme members, what they are showing you, and you kind of use your meteorology training to ask yourself, does this make sense, and is this a reasonable worst case scenario, and that is what we communicate to the emergency managers and the government officials as well. So as meteorologists, we communicate the different scenarios, and then it's really up to the policymakers, to the decision makers, to to make sure the community is prepared. So we work together, but we do have our distinct responsibilities. So hopefully that makes sense. And let's see. Yeah, I think that's pretty much it for the Q&A session. I think because we have already 10 to 15 minutes past time, and most of you have stayed to the end, so I think at this point we'll just call it a night. And tomorrow we do have a marginal risk for severe weather. The main threats would be if you live in an area which is covered by the flash flood watch, like what I said, it's not a warning, but in the case where it gets upgraded to a warning, you need to be prepared where to go to higher grounds, and be alert to have a way to, or even two ways to receive weather alerts. And so basically we have a slow moving cold front that's going to move through the area, and the environment is actually conducive. If storms form and they do become strong or severe, you could have an isolated tornado along with isolated damaging wind gusts. But don't be surprised that maybe you see a shower. It doesn't do anything, because the setup is going to be isolated in nature. So and that's why we have the marginal risk, which is basically level 1 of 5 for severe weather. So but definitely stay weather aware and have ways to receive alerts. So at this point, thank you for attending, and thank you for staying beyond 8 p.m. We always appreciate your attendance. And if you have any questions, be sure to email Joe. So he's not here tonight, but here's his email address. And be sure to, if you enjoyed tonight's webinar, if you think there are ways that we can improve, be sure to shoot him an email and tell him what went well, what could be better. And we hope to see you at our next webinar. And thank you so much for your time.